You have a system of equations, 3x plus y is equal to negative 14, and then 4x plus 3y is equal to negative 22. They want to know, is negative 4, negative 2, is that the answer to that system? Or is it an answer to that system? So the way you're going to tell that is you're going to plug those in for x and y into each equation and say yes or no. Okay, so if I plug in negative 4, 3 times negative 4 plus negative 2 is equal to negative 14. Is that true? That's what we're trying to decide. Is that true? So negative 4 times 3 is negative 12 plus negative 2. That is negative 14. So it works in the first equation. Let's check it to make sure it works in the second, because it has to work in both of them. If it just works in one, that doesn't do it any good. We've got to have it working in both of them. So we'll plug that in. 4 times negative 4 plus 3 times negative 2. We want to know, does that equal negative 22? We're trying to decide if that's true or not. So that'd be negative 16 plus negative 6. And that is negative 22. So yes, it is a solution to that system. Okay. If either one of those doesn't turn out to be the same, then it's no. Want to go back. If one of them works and the other one doesn't, you might want to make sure you got your signs right and everything's worked out correctly on the one that doesn't work. But it's got to work in both of them, or it's not the answer. Okay, it's not a solution if it doesn't work in both of them. Okay. Let's look at number 5. We'll do 2 out of this set. That'll leave you 3 that you can practice on. Number 5, you got y is equal to 4x plus 2, and then 4y plus 16x equals negative 24. So on this one, they're being a little bit tricky, and they're trying to disorganize the thing and get x and y in the wrong spot, make you plug it in the wrong place. They want to know, is negative 1, negative 2 the solution to that system, or a solution to that system? Is it? Because it could have infinitely many solutions. We don't know that for sure. So the best way to check, just plug it in, x and y. Does negative 2 equal 4 times negative 1 plus 2? That'd be negative 4 plus 2. And negative 4 plus 2 is negative 2. And it works in the first problem. Good to know. We got to check it in the second problem. Okay? So that's 4 times negative 2 plus 16 times negative 1. We want to know, does that equal negative 24 when you work that out? That's what we want to know. Okay? So that'd be negative 8 plus negative 16. That'd be negative 24. And it's the same on both sides. So it does check. So this one is a yes. It is the solution. If either one of those doesn't work, it's no. We're just picking the x and the y they give us. You're going to be given that. Decide, does it work in both equations? If it does, hey, it's the answers. If it doesn't, then no. All right, let's look at the second set. This is to solve the systems by graphing, okay? We're going to solve these systems by graphing. So we're going to have to graph the lines, okay? Pick me one. Which one? 10? 10 looks like a good one. It's got the fraction in it. X plus 1/4 y is equal to 6. And then we have this other one that's x equals 5, which is just a weird one. That seems weird. So anytime we got x and y both in the equation, we want to take that and get it in slope-intercept form. Okay? Every time. If you can put it in slope-intercept form, put it there if you're going to be graphing it. Okay? So let's get y by itself on the first one. So we subtract x. So it's going to give me 1/4 y is equal to negative x plus 6. And then how do I get y by itself? Divide by 1/4, that'd be the same thing as Yeah, I'm multiplying by that reciprocal of 4. So I'm multiplying that entire side by 4. Ugh, that makes it a big number over there. Okay? But that's okay, because the slope's not a fraction now. It's negative 4x plus 24. Okay, so we're dividing by a fraction is the same as multiplying by its reciprocal. It's the y-intercept. Now, you can graph using other points that are not the y-intercept. But, as far as graphing that line, now I'm going to show you how I would do this on a smaller grid without having to draw such a huge graph. Because the negative 4 came from this negative 1 right here times that 4. So I multiply 4 times both sides. There's a negative in front of that x. So negative 1 times 4 is negative 4. That's where that's going. Because when I moved this x over here, it became negative x. Okay. Now, from there, the other ones can't be put in slope-intercept form. It's just x equals a number. So what do we know about that line? It's vertical. Good. So it's a vertical line at 5 on the x-axis. Okay. So I'm going to draw this on the coordinate plane. I'm going to show you how I would fix this so it's not such a huge graph. Yeah, I can change that scale. That's exactly what I'm going to say. And I'm going to go by 4s because my slope's a negative 4. So going by 4s, y's by 4s. That's what y times 4. So that means every block on the y-axis means by 4. So the y-intercept of 24 would be at 4, 8, 12, 16, 20, 24. It'd be right there at the 6th line up. Okay. And then the x-axis, I'm going to be, I'm just going, the x is normal by 1s. Because I don't need to shrink that down. But if I'm going to finish that line, the negative 4 be down 1 over 1. Because each block, remember, counts 4. And I hadn't looked at the solution. This may come back to bite me on that. Over 10. No, it's not. It won't. So then I'm going to graph the x equals 5. So I'm going to go over to 5. 1, 2, 3, 4, 5. And my line is off a little bit. Let me redraw that line. This is where being very precise with your... Can I get a straight edge? Yes, the black box up there has got the straight edge. So please, by all means, if you need one, go get it. Yeah, that's better. All right, so 5, 1, 2, 3, 4, 5. There's my line. There's the point where they cross. I changed the scale of my y-axis and went by 4s. So I didn't have to draw such a huge graph. And yeah, you can change either of them. You can change either one, both of them, or just one of them, and it works okay. No, you don't have to. A lot of times you will, but you don't on that one. Okay. Okay, I'm just kidding. You okay? All right. So over here, Jordan, kind of to clear you up a little bit. Right here, this is a 1 in front of that x, right? So when I subtract it, I'm subtracting 1x. And that's where that's coming from. And then to get rid of the 1/4, I multiply by its reciprocal, 4. So when I multiply it over here, it cancels out, and that's y. But I'm multiplying the whole right-hand side by the 4. That's 4 times negative 1, that's the negative 4. And then 4 times 6 is the 24.
So they actually meet at 4, 5?
At 5, 4. 5, 4. Yeah, they actually meet at 5, 4. And you could check that with the equations here. X equals 5, that works, because 5 equals 5, that one works in that one. So if I plug in here, 5 plus 1 is 6, so it checks in that. So the solution that I found checks in the equations. Okay. All right. Pick me another out of that set from 6 all the way to 14. I know it's another set of instructions there, but we did those the same way. Anywhere from 6 to 14. Pick me one other one to do. All right, number 12. Got x minus 3y is equal to 8. And then we have 2x plus 3y is equal to negative 11. And we want to solve this system by graphing. So I want to take this equations and get them in what form again? Slope-intercept form. Now it's going to end up with fractions in there, but that's okay. Yes, sir.
Oh, I'm going to slap this fly right here. That's what
Oh, I
was
thought you
doing.
was raising your hand. Okay. So I'm going to subtract the 1x. All right. And that's going to give me negative 3y is equal to negative 1x plus 8. Okay, so I've subtracted the x to move it over to the other side. And that left me the negative 3y, a negative 1x, and an 8. And then how do I get rid of the negative 3? Divide by negative 3. So that one's going to turn into y is equal to positive 1/3 minus 8 over 3. We're getting y by itself is all we're doing there. All right, so the second one, subtract 2x. To get it to cancel out, got a 3y here. We're going to divide both sides by 3. Negative 2/3 x minus 11 over 3. So we got fractions all in that, but that's okay. We can still graph it. Yeah. I love them. They're fun. No, yeah, regular integers too easy. Okay, so let's graph the red one, the 1/3 x minus 8 over 3. So negative 8 over 3 is what? Yeah, negative 2.6. That's what we want to think about when we go to graph that. So negative 2.6. So it's a little bit past halfway on the y-axis. And then we're going to go up 1 over 3. Up 1 over 3. I could go down 1, left 3 if I want to. I'm not sure where they're going to cross at yet. I know they're going to cross y. How do I know these two lines are going to cross? Different slopes.
Did you do that wrong there?
Did I?
You're on 2. Yeah, you're on.
I did negative 1 and...
Okay, I was about to say, I think I read that wrong.
No, you're all right.
We got you.
Thanks. Appreciate it. Been a long day. Okay. And then I'm going to graph that line. So I'll draw that line. Didn't do too good of a job there. Try to do a little bit better. It's easier to do with a pencil more accurately. And then we have negative 11 over 3 as the y-intercept for the blue one. That's negative, how much? 3.6. There's 3. 3.6 is there. And it has a negative 2 over 3 slope. So down 2 over 3. Up 2, left 3. Looks like they're going to cross at a nice spot there. That point right there is where they cross. That's negative 1, negative 3. Looks like. And that's the ordered pair. Let's see. So if I go back and check that, negative 1 minus negative 9 would be positive 8. and then -2 minus 6, minus 9 is -11. And multiply. Slope intercept form, graph them, see where they cross. They should be crossing at nice ordered pairs, not fractional ordered pairs. If you noticed on the answer key there, none of those had wild answers. They were nice integer ordered pairs, meaning not fractions, not decimals. If you work one of those and they don't cross in a nice spot, then either your line is off by just a touch, one way or another, or maybe you did the slope wrong or something like that. Okay?
Why is it right up under the 0 whenever it's -8/3? How does that make it?
It's the y-intercept of -8/3, which is -2.6. -2.6 on the y-axis is right there. That's what that number. This number out here is the y-intercept. This number in front of the x is your slope, and I think that's what you're confusing.
No, I know my slopes and I know my y-intercept, but I don't know. I don't understand the graphing part. I don't understand how.
She don't understand how 3 will go into 8 2 times with that leftover.
No, like, I don't understand any of it. But I'm trying.
This is, you divide 8 by 3, like calculator style, and you get -2.6. So when you go to graph the y-intercept, if it's a fraction, think of it as a decimal, because that's easier to figure out where it's at. So like -8/3, we don't really see that as easily as we see -2.6, right? That makes sense that a fraction's harder to see. If it's like 1/2 or 1/3, we do understand those, but these improper fractions are a little tougher. So you want to think of them as fractions when you go to plot the y-intercept. So like here, -11/3, do that division, and that's how we get -3.6. And so that's why that point's right there at negative. So you just do that division with that number. Now the slope, we left it in fraction form because the slope's easier to do when it's in fraction form. Slope as a decimal is really hard to do. Slope as a fraction, it's rise over run. All I got to do is count up or down and then over. So that's a lot easier to do. So that's why we leave them as fractions. But when you go to graph them, think about them as a decimal.
What do you do when your dots don't line up? Like, you ordered it right between 2 and 3, right? And on your straight line, it don't add up. Like, it's only, you can't draw a straight line out of that.
On the red one, when I start there, when I count my rise over the run, I think this will help you, Jordan. When I count my rise over run right here, my point is right here. So when I count up, I don't go to one of the lines that's already drawn. I go up to a 0.6 of the way in between. So I'm going to the same place in between to go up 1 and then over 3. And then on this one had a -2 slope, or -2/3 slope. I was 0.6 of the way. So when I went I went to the 0.6 of the way down. I didn't go down to the line on my graph paper. I went to the 0.6 part, and then over. Down 2 of those units, and over. So maybe if I draw that's what I'm doing. That's how I'm getting to that straight line point. Your calculator can put it in for decimals. So like, if you type in a fraction, 2/3. Mine gives, if it doesn't give you that answer in decimals, then you need to hit mode. And then you need to change it, your answer type, to I change it to automatic or decimal. If you want answers to be in decimal, I want mine to be in decimal form, and then I change it to fractions if I need to. Okay, and the way to do that with the graphing calculator is you hit, like, let's say I got a decimal answer there on my screen. I got an answer there. If I want to change that back to a fraction, I hit math, enter, enter. and it changes it back to a fraction. It'll do the same thing. If you get a fraction as an answer and you want to get a decimal out of that, if you'll hit math and then go down to where it says arrow DEC, that changes it to a decimal. And then hit enter after you go back there, and it changes it to a decimal for me out of that. All right. Maybe that got a little bit better then. Let's do one more out of that set. Let's get number 14. We got the instructions say use this with the graphing calculator, and I'm going to show you how you could check some things with this with the graphing calculator in just a second. But I want to show, we definitely need to be able to graph a line without the calculator. This one maybe actually be a little bit better because, well, no, that y-intercept's going to be bad on the first one, but that's okay. All right, so get them in slope-intercept form. Subtract x. Negative x plus 13. Divide by 6. Y is equal to negative 1/6 x plus 13 over 6, which we know 13 over 6 is what? 13 divided by 6. 2.16 or about 2.2 or close. 2.2. About 2.2. That's where we're going to eyeball it at when we go to graph. It's great to get the other one in slope-intercept form. This one works out a little bit better because we've got 12y. Not quite perfect, but it is, at least that fraction reduces some. Divide by 12. And we get negative 1/6 x plus 7 over 6. So, do we even have to graph this one? Why not? Why is it no solution? They're parallel. How do we know they're parallel? Same slope. The slopes being the same and the y-intercepts being different, that tells us that these are two parallel lines. We really wouldn't have to graph these at all to get the solution to be no solution on this. No solution. Yeah, you very well could have. I mean, it's on the review, so you'd think maybe one or two would be on the test. But again, most of the time we're getting an answer, right? Most of the problems you get, you're going to have one solution to. But there are going to be times where you have no solution. There's going to be times where you have infinitely many solutions when those two lines are exactly the same y-intercept, same slope. Okay, so we knew from the slopes being the same and the y-intercepts being different that that's no solution. So we didn't even have to graph that one. Okay, all right. 15, 16, or 15 through 23. The instructions say to determine the number of solutions to the system. So what are our possible answers for that? One solution, no solutions, or infinitely many solutions. Consistent and independent goes with which? One solution. Consistent and independent, or that's one solution. Consistent and dependent is infinitely many. So that's when there's one line drawn. And then inconsistent is no solution. What's that look like? Parallel lines. So we look at that 15, those two lines intersect at one spot. So there's how many solutions? One, you would call that consistent and independent. We look at number 16, it looks like they didn't finish the problem. It looks like they only drew one line, but technically there are two, and they just happen to be the same one. So that would be consistent and dependent and infinitely many solutions. Okay? Flip over there to 17. We'll just go through.
Consistent or
You would tell me the number of solutions. If there's one solution, you say 1, and then say that it's consistent and independent. So you would tell me both of those things. If you tell me it's consistent and independent, that takes care of both. Okay? If you tell me it's consistent and dependent, that tells me that there are infinitely many solutions. But to be safe, write both of them. So we know both words that go with that. 17, how many solutions? 1, and that would be consistent and independent. Number 18, same answer.
1.
Yeah. Number 19. 19, no solution, so that would be called inconsistent. Good job. All right, so these are the easy ones. These are the ones you're going to feast on to get these right. Number 20. One solution, consistent and independent. Okay. Number 21. Infinitely many solutions, so that would be consistent and dependent. Yeah. And then 22. One solution, consistent, independent. 23. No solution. It's also called inconsistent. Knowing those vocab words is the key. Okay. All right. 24 through 35 is the same idea, but it doesn't draw the graph. Okay, so this is where we get that understanding about when do we even have to draw a graph to get a solution. The instructions say determine, without graphing, determine the number of solutions for that. Call it consistent and independent, consistent and dependent, or inconsistent. Same thing as we did on the previous section. Okay, so when we look at those, let's just take 24 for example. You got x plus y is equal to negative 6, and then you have y is equal to negative 2x. What do we need to look at in order to decide what's going on? The slope. Okay, how do we find the slope of the first one? Well, I'm going to get y by itself. Negative x minus 6, and then this is y equals negative 2x. Are those the same slope? No. So what do we know? Yeah, one solution, consistent, and independent. Because the slopes are different. Doesn't matter what's going on with the y-intercepts. The slopes are different. Let's see. 25. Got to get them in slope-intercept form to decide. 26, you got to get them in slope-intercept form to decide. 27, get them in slope-intercept form, decide. 28, get them in slope-intercept form, decide. If there's one you want me to work, let me know. If there's one you're like, okay, I'm not sure about that one. Let's work that one together. So pick me one out, and we'll work it. Let's look at 26. That's a good one to look at. 26, it's got y minus 4x is equal to 3. And then the second equation is 4y equals 16x plus 12. Okay, I'm going to get y by itself on the first one. And just one step to do that. There's y is equal to 4x plus 3. The second one, it's one step as well, but it's a different one step. I'm going to get rid of the 4 by doing what? And it ends up being exactly the same equation?
No. The slope's not negative.
Slope's not negative in the first one either. So it is exactly the same. So these two match. So that would be infinitely many consistent, and dependent. Consistent and dependent. Infinitely many solutions, consistent and dependent on that. If everything's the same. Yes, it's only dependent when everything's the same. It's independent when their slopes are different. It doesn't matter about anything else. Mm-hmm. Yeah, that's that. They're independent lines because they go in different directions. Usually independent people go in different directions. They don't all follow the same suit, right? That's the way I've always remembered it, that independent meant you went your own way. You may cross paths with somebody at some point, but you go your own way. If you're dependent, that means wherever one goes, the other one goes. Y'all answer that. How do we know when it's inconsistent? Parallel. And how do we know two lines are parallel? Same slope, but what? Different y-intercepts. So the parallel, that's inconsistent, that's the same slope and a different y-intercept. That's how you're going to know that. Okay. Pick out one of those. Number 20, number 30. Let's look at number 30. That's a good problem to kind of help Dalton with his question there. We got x plus y is equal to -1, and then they have x plus y. I don't know why I scooted over. X plus y equal to 0. Okay, we can already tell that those two equations are very much alike, but let's get them in slope-intercept form so that we can talk about the slopes being the same or different. So I would subtract x, y equals -x minus 1. Yeah, they are the same slope because when you subtract x here, you get y is equal to -x. Technically, there's a plus 0 out there. You don't usually write it, but it's out there. Slopes are the same. So that means, and the y-intercepts are different. This one has a y-intercept of -1. This one has a y-intercept of 0. So that's why this would be no solution. Because these slopes are the same. Both have a -1 slope. So no solution. Or inconsistent. All right. Let's get to everybody's favorites, the linear inequalities, the shading stuff. And this is where some of us struggled a little bit. We could get the line drawn, but we struggled on the shading part on some of this. And some of us, struggled with all of it, I'll be honest, with the lines and that. So let's try to get to the improvement on this. I think it's doable for us. So let's try and get there. So number 36 through 47 are the linear inequalities. Okay, so let's pick one or three to work here. So give me one that you want to see. 43? All right, yeah, that one's got a lot going on. 43, we got y plus 4x is greater than or equal to -1. And then we have 3x minus 2y is less than or equal to 16. Okay, so this one's got a lot going on. So let's get one of them done first. Let's get the top one there. We'll get y by itself. Slope-intercept form is still the name of the game because we're still graphing. Okay. Going to subtract 4x greater than or equal to -4x minus 1. That's got y by itself. It's ready to graph. Okay. I'm just going to go over here and get my coordinate plane drawn. Get ready to graph that thing. All right. Let's go ahead and graph that one, and then we'll get the next one. Okay. While we're thinking about this one. So where do I start with this? -1, the y-intercept, -1. Point right there. And then my slope is down 4, right 1. Yeah, so down 4, right 1. I could go up 4, left 1 if I wanted to. Now, the next thing to decide on inequalities is what kind of line to draw. Why is it solid? Got an equal to mark, so it's a solid line. Good, 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 good. Then we need to decide about shading. Okay. This one gets real, real close to the origin, but it doesn't go through it. So I can use 0, 0 as a test point here. So if I plug 0, 0 into my problem, I could go to the original or I could go to what I've worked. Doesn't matter which one you go to as long as you did it right. Okay? If I go here, is 0 greater than 0 minus 1? Yeah, 0 is bigger than negative 1, right? So that means I'm going to shade the side that 0, 0 is on. So I would end up shading this, what we could call the right-hand side of that line. Or maybe the top side of that line. Okay? All right, now let's graph the second one. So I'm going to get y by itself on the second inequality. So I'm going to go, what am I going to do? Subtract the 3x. Negative 2y is less than or equal to negative 3x plus 16. Divide by the negative 2. That's a big deal. If I divide that by negative 2, what happens? The sign switches, the symbol flips. Okay? So that's going to give me y by itself. This flips around to y is greater than or equal to, then that's positive 3 over 2x, and then negative 8. Why did the sign? Anytime you multiply or divide by a negative on an inequality, it flips the sign. Has to do with the direction that you're going in the. Anytime you multiply or divide by a negative sign, it flips that symbol because it changes the direction your number line is going. Like your graph would be going on a number line. Alright, now let's graph that on our coordinate plane. So y-intercept is negative 8. 2, 4, 6, 8. Slope up 3 over 2. Dotted or solid? Got an equal to mark, right? So it'd be solid, right? Be careful about that. And now I want to do my shading. So I'm going to check. I'm check the origin here because the line doesn't go through it. So 0 greater than negative 8. True. So I'm going to shade the top half of that line. So this area that's in green here, that's my solution area.
How do you know what side they're shading?
By that test point that I'm putting in there, I'm checking 0, 0, Jordan, and 0, 0 is right here. It's on this side. If I plug that into my inequality, I get 0. I'm testing is 0 greater than 3 over 2 times 0 minus 8. So that's where I'm getting, 0 greater than negative 8. If it's true, which this one is, I'll shade the side my test point's on. Because I know 0, 0 is here, I'm going to shade this side that it's on. If it were false, I go to the other side of that. I think some other teachers say if it's greater than, you're going to go above it. If it's less than, you'll go below it. But that kind of, to me, that's more confusing because once that line gets pretty straight up and down, where's above and where's below? And if you're right-handed or left-handed, it may affect your judgment on that as well too, because the way you look at it is different. So the test point always works. So if you plug it in and work it out. All right. Pick me another one out of that set. one in particular? 40? Yeah, 40's got y is less than or equal to negative 3x plus 3, and then y is greater than or equal to x minus 9. So those are already in slope-intercept form, so they're ready to graph. Doesn't matter if they're parallel or what. When you're doing inequalities, it doesn't matter. You're still going to graph everything. Okay, so I'm going to draw my coordinate plane. I don't have to do any work to get these with y by itself, so that helps. So I'm going to graph this first one.
And the ones on the test be like that.
Some of them will. I won't say all of them, but some of them will. Okay. So y-intercept of 3. Slope down 3 over 1. You do that a few times just to get a nice, accurate line. Solid or dotted?
Solid.
Why? Because it's got the equal to mark. I want to be pretty precise with my graphing here, but I don't have to be quite as nitpicky about it with the inequalities as I do with equations, because I'm not really concerned about one place where they're crossing. I'm looking about where's the shading overlap. Okay, so that's the next step on this one, is the shading. So can I use the test point 0, 0? When can I not use that?
When the line goes through.
When the line goes through the origin. That's when you cannot use that. Okay, so I'm going to go 0 less than or equal to 3. Is that true or false? Is 0 less than 3?
Yes.
Yeah.
It's true.
It's not equal to it, but it's less than. So that would be a true statement. So that means I'm going to shade this side, or left side, or right side?
Left.
Left. 0, 0 is right there, and it's true. So I'm going to shade this side, left side. Do, 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 do. A test point tells you which way to shade, Jordan. That would be, that's how I decide which way to shade, because it always works. I tend to.
I'm just wondering where do 20 steps to do that.
I ain't gonna have none.
Maybe algebra 1. All right, so y-intercept on the second one.
Negative 9.
Here we got 1, 2, 3, 4, 5, 6, 7, 8, 9. The slope's 1. The y-intercept is negative 9. Okay. Dotted or solid? Solid. Got the equal to mark. I didn't do a very good job drawing that line. I'm going to try again. That's better. Not great, but it's better. Okay, now let's get the shading done. I'm either going to shade above it or below it. So I'm going to plug in 0, 0. Is 0 greater than or equal to negative 9? 0 is bigger than negative 9, right?
Yes.
So I'm going to shade above it, so the top side of that one. Yeah, all this area over here on the left is my solution area. Did I misread the problem?
I did that too whenever I shaded.
Number 40?
That's what I did when I shaded mine.
It very well could be. Yeah. It is wrong.
It is wrong?
Yeah, the answer key's wrong. The answer key's wrong.
Okay, well,
Guys, I
see
don't
what
go
I
by the
think
answer key that
mine.
this stuff, I work every test you do. Y'all probably
This
don't
is
know
what I
that,
did
but I
on
do.
number 40 when I looked at that.
Yeah. If you shaded it like this to begin with, that's the right one. So this is your solution area over here. Yeah. Alright. Pick me another. We'll do another one out of that set. $47. Oh yeah, let's get that one.
This is definitely gonna help me on the test.
It should. So got 4x plus y less than 21, and then we have x plus 3y greater than, equal to, greater than 19. So I'm going to get y by itself on that first one. Subtract 4x, 4y, not 4y. Y is less than negative 4x plus 21. So pretty big y-intercept there, but that's okay. We'll work with it. And then let's get the other one, y by itself. So I subtract x. I want to keep putting an equal to mark there. Divide by 3. So I end up with a fraction there. And I didn't divide by a negative, so I don't flip my symbol. Be careful of that. Look for those things. Anytime you... Only when you divide by a negative or multiply by a negative to solve. Like if that was a negative fraction there, you would multiply by the reciprocal and it'd be a negative. That would flip the symbol around. That's the only time that happens. So that's negative 1/3 x plus 19 over 3 is 18, or is 8, not 8, 6.3 repeating. So I'm just going to rewrite it. I'm rewriting it in decimal form there because I'm going to graph this. So that's where I'm thinking is 6 1/3. So, when I go to graph this, I've got a y-intercept at positive 21 and then a y-intercept at positive 6 over 3. That's a pretty good gap. So going by 1s might not be the best of methods, but going by 3s might be, because 3 and 6 are both divisible by 3. So that's what I'm going to do. Well, I'll tell you what. My slopes wouldn't work too good like that, though. I got just enough to go to 21 there. The top point on my graph was a 21. All right, so the graphing part of it is you're going to look at your slope-intercept form equation. And whatever number is out here, that's where you start on the y-axis every time. So I'm going to go to 21 on the y-axis. So I just happen to have enough room here. And, you'll have a piece of graph paper tomorrow for the test, so you can graph it by hand if you need to. Okay? And then, so 21, and then I'm going down 4 over 1. For the slope. The slope is what's in front of x. So I'm going down 4. 1, 2, 3, 4 over 1. Now I'm going to do that again. Down 4 over 1. And I'm just going to do it one more time. And then that's going to be what kind of line? Y dotted. No equal to mark. You got to remember that because that's... As you guys know that like your end of course test is going to be like some multiple choice type problems. Some of your tests tomorrow will be multiple choice. And they're going to graph the same two lines. One of them's going to be solid and the other's going to be dotted. It's going to have the shading exactly the same, but one's solid, one's dotted, just because that's the way multiple choice tests are done. They don't just randomly pick wrong answers. They give you wrong answers that could be found using the equations that you have. All right, so let's get this one. Graph, we're going to 6.3 for we got to shade that one. I forgot. Shading. 0, 0 is 0 less than 21. Yeah, so I'm going to shade left side of that thing. That area. 6.3. 2, 4, 6.3. So about 6 1/3. And then I'm going down 1 over 3. So when I count my down 1, I don't go to the lines that are already drawn. I go about 1/3 of the way up from it. Down 1 and then over 3. My next point should be right there. I wish I could put that point there, but I couldn't. Those boards are expensive, so I don't guess I'll ever have one of those. And then dotted line again. I'm going to check 0, 0. 0 greater than 6 1/3. No, so I'm going to shade away from the origin, which would be this top half here. So the answers will be in that overlap section. So this is your solution area. Here's your solution area. Sure, we'll go over as much as we can before the bell rings. The piecewise are tough, no doubt. College Algebra's doing some. Theirs are a little bit more complicated than these. They got different kinds of equations in them, but they're same idea. Yes, ma'am. Sure. I'm going over 48, 49, and 50. I'm going over all three. Is that okay? All right. 48. We got 13 minutes. I think I can get them done in 13 minutes. I did 5 of them in 6 minutes the other day, so for that video that's online. So we got x minus 4 if x is less than 1, and then we have negative 2 if x is greater than or equal to 1. Okay? So the main thing that you guys kind of fall into when you start doing these piecewise is you try to do all of it at once. My college algebra class does the same thing. They try to do all of it at once, and you can't. It gets too complicated. Some of you maybe can, but it's easier if you just do one piece at a time. Okay? Kind of like how do you eat that, huge burger that they have over at Outpost? One bite at a time. So we're going to take one bite at a time. Let's take the first bite, that x minus 4, if x is less than 1. Okay? So that first bite, I need to find out what's the important point for that one. Well, that comes from the x is less than 1. That 1.
Is that Bigfoot they got carved over at that one?
I hadn't seen that. I didn't.
Yeah, I started with chainsaw.
That's crazy.
That thing's like $10.
Wonder if he had somebody stand there and pose for it. Like a real Bigfoot. A pet Bigfoot.
No,
Right. From right here, that 1 that's right there, I'm plugging it in here so that I know the important point for that part of the graph. Okay, whatever x's are out here, that's where you're going to get them. Okay, if there's one x out there, there's going to be one important point. If there are 2 of them, like when we get to number 50, you'll see that there are 2 of them for that one, so we'll have 2 important points. Okay, now, so when I go to graph that part, I'm just graphing the x minus 4 part. I know that at the point 1, negative 3, there's something happening. So I go to the point 1, negative 3. I'm going to put an open circle. Why is it open and not filled in? Because it's not equal to. The same way the dotted and solid line works with the inequalities. Okay? So not equal to, so that's an open circle at that important point. Now here's where I've got to figure out which direction to go. It tells me that x's are less than 1 if it looks like this. So is that going to go this way or to the left? To the left, because there's 1, there's 0, that's less than that. Okay? There's 2 different ways to get that graph part. One way is to plug in x values. So I could plug in 0, because that's less than 1. 0 minus 4 would be negative 4. I could plug in negative 1, because that's less than 1, right? Negative 1 minus 4 would be negative 5. I could plug in, I could keep doing that. And I know that line's going to keep going. I know it's a line because this is x minus 4. That's a straight line. I know that's a linear thing.
How do you know they go from the side?
Because it's slope-intercept form. This is y equals mx plus b. The slope's 1. That's what that is, really. Okay? Now, I did it. You can always plug in x values that fit the if and get points and figure out what's going on.
Why can't you just go one, do like regular problems and one go up 1 and another 3?
All right, for this one, I would go, like that point 1, negative 3 is right there. This, I need the slope of 1. I could use that, but I need to go this direction with it. If I go up 1 and right 1, it goes the wrong way. I could go down 1, left 1, and look, I end up on the same point I found. Down 1, left 1, I end up on another point I found. So that's the other way of doing it. Yeah, I know I got to go left because that tells me to go left. No.
It don't matter on this.
Dotted and solid doesn't happen on piecewise. That only happens on the inequalities.
It's the circle that matters. How do you
Hmm?
how do you know what the slope is?
What's in front of x? That's the slope. Because that line, that part, y equals x minus 4, that's slope intercept form, right?
So
We just know that that's only happening up to this point. It's that graph. Okay? And then I need the important point for the second part. So I've graphed the first part. I used the important point at 1, -3, and then I use that slope, but down 1, left 1, down 1, left 1, or I plugged in 0 for x and -1 for x and worked them out and got points. Follows that line. Then this part, it's y equals -2 for x's that are greater than or equal to 1. So at 1, these are a little bit confusing because there's nowhere to plug that 1 into. So -2 has to be the answer for it. So the point 1, -2 is a filled in dot because it's equal to, right? So that's why we fill that one in. And now, what does the slope, or what does the equation y equals -2 look like? Y equals the number is straight line, straight across, right? So it's going to go straight across. Which direction? Y right. Well, it's greater than tells me to go to the right. That's correct. Greater than tells me to go to the right. X's that are greater than 1 are in that direction.
So it's supposed to look like it.
Yes, should look like what you've got drawn there. Okay. There's a piecewise graph. Not quite as painful as we're making it out to be. Let's look at 49. You got 7 minutes. I think we can do it. Well, I think this one will go better because it's the second one. It's getting easier. X is less than 2, and then we got 2x minus 3 if x is greater than or equal to 2. Most of the time, these numbers are the same, but they don't necessarily have to be. So don't think that it's wrong if they're not. They don't necessarily have to be the same. All right, so important point for the top piece. Well, the x value that's important is what? 2. So I'm going to plug 2 in. And 2 times -1 is -2 plus 3 is 1. 2, 1. Open circle. Why open?
So did you do -2 times 3 plus 3?
I did, yeah, -2 plus 3 is where that 1's coming from. Exactly right. Okay?
You can go fast. It's only reason I get messed up. It's fine.
Get back to it. All right, so which direction am I going with this one? Why left?
Negative.
It's less than. It's lower than 2. Okay? I've got a slope right there, right? I can count it to the left. How does a -1 slope work to go to the left? Up 1 and... I can't go down 1 and over 1 because if I go down 1 and over 1, I'm going to the right. Remember, I got to go left. So I got to go up 1, left 1.
Why do you have to go left?
Because of that. X's that are less than 2 tells me to go to the left of 2.
Yeah, but you can go to the left too if you go down 1 and left 1.
That's not a -1 slope.
No.
Down 1 and left 1 would be a +1 slope. Remember, negative slopes fall down and to the right. If you went down 1, left 1, you would be going up and to the right. like that. Not the same. Close enough. Completely different. Close enough. It's like if you saw a guy that stole your wallet and you gave him the description and it was nothing like the guy who did it. I don't expect him to catch him.
Close
If
enough.
it's the same thing, what do you do then?
Say that again.
Close enough.
Same thing.
Okay, good. That's what's going to happen here, right? Because when you plug in 2, you get 4 minus 3, and then that's 1. So that important point, Jordan's ahead of us here. She's moving faster enough. So got 2, 1. That's the important point. It happens to be the same one. We've already got an open circle there, so just put you a filled-in dot inside of that. You can kind of see my outline around it that says that was an empty circle there. And now I'm going to follow my slope of 2. Up 2 over 1, up 2 over 1. I'm going to the right because it says what? Greater than 2. So that's why I'm going to the right, toward 3, toward 4, toward 5. Because those are bigger than 2. And I draw that little piece of line there. And we've got that graph. Okay? Uno más. Good. You paid attention in Spanish class. Good job. No comprende. Do I know what that means? Yeah, I don't understand why you would want that. No, you don't.
After doing this.
No. Then you won't remember how to do any of this. You'll fail the test tomorrow. No, thank you. All right, so this one's got a lot more going on because it's got 3 pieces, right? How many important points are there for the first part? 2, because how many x values did they give us? 2. Okay, so we got to find them. I'm hurrying, man. I'm going as fast as I can. All right, so I got 8, -8, -5, and then +2, +5. I got those from plugging in. I'll graph that part. Okay, so -8, 3, 4, 5, 6, 7, 8, -5, 1, 2, 3, 4, 5. Filled in circle on the -8, -5. What kind of circle on the 2, 5? Open. Why? It ain't equal to. It doesn't have an equal to mark. Okay, so that's an open circle. We know that's a straight line because it's in linear form, right? Slope-intercept form. So I don't even have to count slope there. I got 2 places. I can just connect those.
Is that all you do?
For that part, yes.
Oh, since there was 2.
Since there were 2 of them and we know it's a straight line. Okay, now the next piece says -6 when x is equal to 1.
So, 1.
On the second piece, did I miscopy that problem? I did. That is a 2. Thank you. So that's going to be a 2, -6. 2, -6. 1, 2, 3, 4, 5, 6. Filled in dot because it's equal to. Now, it doesn't go any direction, right? Because it's equal to. That means we're stopping right here. We're not going anywhere. That's it for that part. It's just that point. Next part, 2. 2, 2 is the right number. And that would be an open circle with a slope of -1 going to the right because it's x's that are greater than 2 and my slope is -1. So down 1, right 1. And there is my piecewise defined function for that.
May I have your attention, please?